Everyone. So I've come to the realization that these videos are going to be way too long if I continue to draw them as we go. So what I'm going to do from now on is I'm going to have the drawing up here. You can pause the video and draw it yourself, and then I'll explain it to you. I think that might go faster, so that way it's a little easier. So down at the bottom, it says the definition for mechanical wave. It's waves that require a medium to travel through and form when a source of energy causes the medium to vibrate. So mechanical waves require a solid, liquid, or gas in order to travel. So mechanical waves can't travel in space because up in space it's what we call a vacuum because nothing's there. Basically, all of the material is just it gets sucked away, and it's like a vacuum of space. So, looking at this right here, we have a solid, liquid, and gas. And yeah, some of you are gonna be like, "Oh, what about plasma, Mr. Raymond?" Yes, yes. Energy can travel through that too. So, mechanical waves would basically travel through a solid, a liquid, or a gas. Now, that's opposed to electromagnetic waves. Electromagnetic waves, yes, they can travel through stuff. Okay, they can travel through gas, like light, for instance. The sun, the radiation from the sun, right here, is electromagnetic energy. And it travels through space. It even travels through our air, and it travels through this window in this room. So that's a solid. And you know what? If I had a huge pool of water right in front of me here, and the light would shine through that as well. Okay, radiation can travel through mediums. All right, so I tried to draw this in a way that helps you understand where they get electromagnetic from. You see, radiation and electromagnetic waves have both properties of electricity and magnetism. So it's like a two-part wave. And you'll notice the shape of it goes up and down or side to side in reference to the direction of the wave. So once again, mechanical waves, they need a medium to travel through. Electromagnetic waves, they can go through mediums, but they don't need them. They can travel through a vacuum or space. Now, transverse waves. Let's talk about the shapes now. So, going to transverse, and I know I skipped electromagnetic on there, but it's pretty much what we said. Let's go to transverse here. It says wave that moves at right angles or perpendicular to the direction of the wave, of the way the wave's traveling. So the overall wave is traveling in this direction. See that by the arrow. But different parts of the wave are moving perpendicular to the direction of travel. Perpendicular. Whenever anybody says perpendicular to me, I'm like, oh, it's like this. Okay, so it's a 90-degree angle of whatever the other line is. And then parallel is more like this. This isn't a TikTok video, so please don't turn that into a TikTok dance. Moving forward. So you can see that the direction of the parts of the wave, it goes perpendicular, so up and down, versus the overall direction of the wave, which is this way. That's what transverse waves are. Electromagnetic waves are transverse. You can see that right there. Longitudinal waves are waves in which, I'll scroll to it. Longitudinal waves, waves that vibrate the medium in the same direction in which the wave travels. So basically, longitudinal waves, they are mechanical. They require a medium to travel through. So sound is definitely a longitudinal wave. It's definitely mechanical. Sound requires a medium to travel through. So this is a picture of Marley singing. And when you look, by the way, the Alice in Wonderland, her rendition, if you didn't see it, it's incredible. Anyway, these right here, these lines are supposed to represent particles, like of a medium. So like little atoms that make up the medium. So the atoms that make up air. When she sings, she vibrates the air. And the air vibrates this way in the direction of the wave of where she's singing. So Longitudinal waves move in a parallel way, whereas transverse move in a perpendicular way. So parallel, perpendicular. And I know that could be somewhat confusing to some people. It's okay. Just please know that the medium is vibrating the way that you're sending the sound. Um, Whereas with electromagnetic, the actual shape of the wave is perpendicular to the direction of the wave. And then finally, music recording. Those of you who want to record music, let's just link this all together. So when I talk, my vocal cords vibrate, and that causes the air to vibrate, and it sends longitudinal or mechanical waves through a medium all the way to the microphone. The microphone picks it up and it converts it to an electrical signal. So there's part of your electromagnetic, electrical signal, and it moves through this cord all the way to the computer. So here's your computer, and your computer shows little squiggly lines like this. It looks like transverse waves, when really it's converting your longitudinal compressions, like these areas that are close together, and rarefactions. It's converting it to a transverse method because, guys, when you are audio engineering, it's easier to manipulate waves that look like this versus waves that look like this. I'll show you that in the future when we learn sound. So I hope that kind of gives you a little gist of that row. Let's keep going.